Swayam Prabha. Digital India. Educated India.
Welcome back. In lecture 37, we will talk about quantity of sanitary sewage. The different concepts that we will cover is basic sewer design, some basic fundamentals, sources of discharge, population estimate and forecast, per capita sewage flow, daily and seasonal variation in per capita sewage flow, sewage from other sources, and net quantity of sewage. So, when we talk about sewer design, basically what we are doing is the discharge or flow, that is the quantity of sewage per unit time, is used to estimate sewer size for the entire design period. So, there are few terms involved. One is of course the design period and sewer size, that, and then the quantity of sewage per unit time. So, quantity of sewage per unit time is cubic meter per second. So, that is the flow rate or discharge or the quantity of sewage or that is actually generated at a particular period of time. The pipelines has to be designed considering the maximum or the peak flow rate, right. So, whatever is the maximum peak flow rate, that we will consider, and sewer size basically refers to the sewer diameter. So, slope could be also used, but usually what happens, the slope is more or less fixed, because we have a large network. It is not only one sewer line, many sewer lines are there. So, gradually we try to reach a point which from where the sewage is actually disposed into the river. So, we will only be able to go until a certain depth. So, sometimes we use manuals to actually take care of that. So, in between we can change the slope or we use lifting stations to lift the sewage. So, we cannot change the slope too much, right. So, only thing that we can change, and also velocity is more or less fixed, that we have decided that because of scouring or particular optimum range of velocities, we can determine that the only thing that we can play with is the sewer size or the sewer diameter. And the design period is for the timeline for which we are designing the system. So, if its design period is 30 years, that means the sewer should be operating or the sewer should be capable to take the sewage load for till the end of that design period. So, basically useful life of structures and equipments could be related with design period. So, we usually design our pipelines for 30-year period. So, what it means is after that period, in any case we have to replace the size of the pipelines, that sections of the pipeline, and that basically means we have to design till that particular period. It is better to design till that period. So, that actually determines what should be the design period. And flow is largely a function of population served, population density and water consumption. So, that means the flow varies as per water that is supplied to that particular area, the total population that is served, and also on the population density or how concentrated that population is. Because if too much people live in a smaller area, obviously you can understand the flow rate should be higher. Of course, high discharge estimate will lead to larger sewage size, which is of course increases the cost. Whereas, if the lower discharge, then it may not be able to meet the self cleansing velocity criteria. So, too much large size is also a problem, too much less quantity of sewage in a particular area, that means too much low density is also a problem. So, sometimes in underdeveloped areas, as we have discussed in the previous lectures, that even though we will reserve the right of way or reserve spaces to lay down our trunk sewers, that means we should have utility corridors along the roads and all, where under which the trunk sewers and all can pass, or just below the street network also trunk sewers can pass. We should reserve spaces for that, but we should consider alternative sewage systems such as decentralized or on-site systems in case the flow is very, very little. Then lateral and submain sewers are usually designed for peak flows of the population, carrying capacity as per master plan. So, we first determine from the master plans what is the maximum target population for those particular zones, and usually those smaller areas and all are served by laterals or submains. That means not the main trunk line. So, usually we design it for their peak flows. And trunk sewers, interceptors, outfalls are designed for longer period because these are difficult to change. So, even though there is a chance that we may be able to lay some new pipelines for some lateral, some areas of the city and so on, but the trunk sewers, the major interceptors, the main lines, and also the outfall points where the sewage actually falls into the river or the sewage is actually disposed into the river, those cannot be changed. So, pipelines in those areas and all are made once, and that means it has to serve the entire design period. So, when we talk about the source of the sewage that is being generated in urban areas, usually there are three kinds of sources. One is groundwater infiltration, that means lot of groundwater enters into the sewage pipeline. Then there are authorized entrances and unauthorized entrances. Authorized entrances means connection to the sewer pipeline from authorized people or residences or businesses and so on, and then there are unauthorized connections. That means people will connect them, but there is no there is no record of that particular connection because they have done it on their own. So, these are some of the problems. This is actually a problem, that means this needs to be monitored, but this happens in almost all cities. So, the water that comes in through both authorized and unauthorized connection, or the sewage that comes in through those connections along with groundwater infiltration has to be actually estimated. So, water, where does the water come from? The water comes from the water supplied by the urban local body for domestic, industrial and various public uses. That is the water supplied by the municipality, but municipality in most Indian cities supply cannot supply 135 LPCD per capita per day. So, that means even though in some residential units they get adequate water, but in many other places or maybe in the slums those kind of water quantity is not available. So, people use many other sources. What are those sources? Some people use wells, some people use tube wells, some people use lakes, some people use rivers to get water out of them. So, you see that many of the real estate projects in urban areas, they actually draw their water from using tube wells. The municipality is not supplying them. We do not know exactly how much water is being drawn from the tube wells, but this actually is drawn by many of the real estate projects. Then many houses has got wells, particularly in suburban areas and all. Then many in poor areas you see people taking water from lakes or even rivers as well. So, all this amount of water will go into the sewerage network. So, that we have to actually consider. So, and of course, groundwater infiltration like water entering the sewers through cracks and leaky joints, and this again depends on the height of the water table. If it is above the sewer's invert level or the lower level of the sewer and permeability of the ground soil is adequate, in that particular case we will have lot of groundwater entering into the system. So, we have got certain standards for certain thumb rules for that. So, the values of infiltration taken for designing of sewers is something around 5,000 to 50,000 liters per hectare per day, or it could be liters per kilometer per day, 500 to 5,000 this liters. Then liters per day per manhole, that is it could be also estimated based on manholes, because we assume that via the manholes lot of groundwater enter, or it is just a way to refer to it, that is 250 to 500. Right. So, design infiltration values shall be limited to a maximum of 10% of the design value of sewage flow. So, infiltration should be limited to around 10% of the total sewage flow, but we can always also check using these values how much water it is actually leading to. So, we have already discussed that we need to understand that population forecast, and in absence of master plan and other data, some thumb rules can be utilized for that. So, usually the master plan will give us estimate of zone wise population, carrying capacity and all this. But in case we don't have any sort of data, or we don't have data, detailed data on certain urban areas, in that case we can actually, or we want to do a smaller project for a smaller area, for that we don't, it may be a part of the ward, we don't have data for that part. So in that case we go with density of population per hectare. So we will use those particular figures. So usually in we assume that in towns of smaller size like 5,000 people, the density of population is something around 75 to 150, or above 20,000 to 50,000 around 250 to 300, whereas above 1 lakh the density is around 350 to 1,000. So that is the first thing that we will consider, this is the total number of people living in a particular area. So if we know the area of that particular zone, we can assume this kind of densities and can determine how many people are living in that particular zone. The other way that we can consider is to consider the floor space index, FSI, or floor area ratio. So in very developed areas where like very developed cities where we have got high rises and all these things, there is no point of going with this kind of a density assumption, because we would be wrong. So in that case, our floor area ratio is a better indicator, and we also have got land use categories of that particular area. Maybe we know which are the residential buildings, which are the commercial buildings, and so on. For residential part, we can assume that the area of the residential development multiplied by the FAR actually give us total floor area for residences. And then what we can do is, we can assume a floor area of around 9 meters square per person, and then we can determine the total amount of people in a particular area. So that means actual total floor area divided by 9 will give us the total floor area for total number of people living in that area. Obviously, we can also determine the density of population per hectare using that from this particular calculation as well. And when we do that, we can actually use the density figures for other parts of the city as well. So then once we know the population for a particular area, we then need to estimate the total per capita sewage flow. That means how much sewage is generated by a single person. So if we are going for a conventional sewage system or a water carriage system, then you have to assume that at least 100 liters per capita per day would be generated as sewage flow, minimum. So why? Because in many cases, if I go with the assumptions from the municipal supply, that is municipality supplies maybe only 75 liters per capita per day. So if I go with that kind of assumption, then we would end up wrong, because in most of the buildings, real estate projects, they will have their own water supply systems, right. So at least we have to go with 100 liters per capita per day. So this is one. The other is in the entire water that is being utilized either from municipal sources or by this kind of tube wells and all, that is consumed in a particular urban areas, actually the sewage flow, or particularly the dry weather sewage flow, is actually much less than the per capita water consumption. Why? Because of course, there is loss due to evaporation, because we use water for watering our lawns and other places. So, there may be evaporation due to that. Seepage into ground, there is infiltration, then there is leakage as well. So, these are the different issues that these are, you can say these are the different losses in the system. And in arid region, we can say that 40% of what is being consumed actually becomes sewage. Whereas in developed areas, we can say like developed areas in not non-arid region, of course, 90% of consumption goes into the sewage, because there is not too much open area, there is not too much infiltration and so on. So, that means 90% of the consumption goes into the sewage network. So, this is what we can start, but again we can have some thumb rules or some tables for that. So, based on the rate of water supply and population, that is for a population of a city up to 550,000, where per capita demand in liter is around 135, we can say safely that the sewage generated would be something around 115 liters per capita per day. Similarly, if it is from 5 lakh to 10 lakh, usually the supply is around 180 to 200. This is not municipal supply, this is municipal supply plus all other supplies, right. And similarly, the sewage generated would be around 160. and more than 10 lakh people, in that case we have 200 to 225 in water supply, that we have learned even in our water supply part of the course, and then the sewage produced would be something around 180 liters per capita per day. So, similar to water supply, we also have seen that because sewage is basically based on the water that is consumed, whatever is there, and then the sewage is generated out of the water that is being consumed, right. So, that means the more we consume water, more would be the sewage. So, similarly, if there is variation in the consumption of water, it would also reflect in the variation in the sewage flow as well. So, the flow in sewers varies hourly, daily and seasonally, same as the water supply as well. So, similar to water supply, we also have to adopt peak flow rates for sewage as well. So, that means there will be certain times of the day when there will be peaks in the system. That means the flow is much more than the average flow. So, peak factor is basically a ratio of maximum to average flows. So, what kind of peak factors do we assume for sewage? The peak factor, like again we do it based on the kind of population that is housed in this particular city. If it is up to 20,000, peak factor is 3. If it is 50,000 to 7,50,000, it is 2.25. If it is more than 7,50,000, it is 2. Now, as you can see, the higher the size of the city, peak factor is lower. So, that is the basic rule that we will follow. If sewer pipelines are of smaller size, the peak factor is higher, not lower, because it is actually taking care of a small group of people. It is serving a smaller community. Similarly, a smaller city, the variation is more. The more larger the city, there we will find people, things average out. That means some people consume at certain times, and other people consume other times. So, if we take an average, we usually find the peak factor gradually coming down. So, usually in larger cities, the peak factor is lower. Similarly, in larger sewer pipelines, the peak factor is lower. So, a trunk sewer, the peak factor that we will assume is much lower compared to a branch sewer. So, in addition to what we have discussed, like based on population, this peak factor varies, but it could also vary based on the hours of water supply. That means, it can vary based on if the water is being supplied in a 10-hour period for the entire day, or maybe 6-hour period in the entire day. Based on that, the peak factor would vary, because the water only comes at certain times. People throw away water at certain times, people will consume water at certain times more, in other times it would be less. So, that actually influences the peak factor. Topography of the site, the slope of the slide, that will play a role, and then density of population. In certain areas which has got higher density, the peak factor would be also higher. So, these are also some of the factors which will influence peak factor. But yes, we can go with standard rates as given in our manuals, in the CPHEO manual, but the problem is in certain areas there is, of course, in certain cases you really need to check if this factor is having an influence on going to have an influence on the peak factor. So, we can see that the seasonal maximum flow rate comes to around 1.3 times of average flow. Monthly maximum flow rate is around 1.4 times the average flow, and daily maximum flow rate is around 1.8 times the daily flow. So, this could be also considered. So, normal average flow rate and the daily maximum flow rate is around 1.8 times of that. Sometimes 2 times is also taken, and monthly is 1.4 of that. So, same as water supply, we can go for daily into monthly. In that way, we can say that the highest day of that highest month, something like that, in that we can also multiply. But in general, we can, if we do not ignore all this, if we want to design the pipeline, we can stick to these factors which are standards from our Government of India manual. So, we can follow that directly. So, we find that the flow rate at night is around 60 to 70% of the average flow, which is minimum flow is around 1/3 to half of the average flow. So, a little bit less than that. So, as we are discussing earlier, that if the flow is measured near its origin, peak flow is more pronounced. That means, at the more we go towards the upper levels of the network, that is where there are how the towards the origin of the sewage, the more would be the peak flow, or the diameters of the pipeline would be also small, and then the variation would be also higher. Similarly, if we assume the same concept, that means smaller cities, the variation will be more pronounced due to lower length of pipelines and lower travel time. Peak rate of flow, that means less for bigger cities and bigger sewers. So, we can also determine peak flows based on the diameter of the sewers. So, 125 centimeter diameter trunk sewer, so that is 1.25 meter trunk sewer, we can assume peak flows as 1.5 times. For 100 centimeter diameter main sewers, we can assume 2 times. Then branch sewers like 50 centimeter branch sewer 3 times, 25 centimeter branch sewers 4 times. So, you see that the house connection is even less than that, right, 10 centimeter, 150 centimeter, 150 millimeter, so 15 centimeter. So, even there it could be even pronounced than this. So, the overall variation between the maximum and minimum flow, not average and maximum flow, is more in the laterals and less in the main or trunk sewer, and the ratio could be even 6 for laterals and 2 to 3 in case of main sewers. So, this is the amount of variation in sewage flow. Now, as you can understand, if I have a circular sewer, sometime it would be flowing like this, sometime it would be flowing like this. So, or like this. So, we have to think about, if flow is like this, the different problems arises. If the flow is almost filled up, then other problems arises. So, we have to design our pipeline considering both the extremes of this kind of flows. Then we, in addition to residential areas, we were talking last time about the residential areas. So, what about the non-residential areas? So, for non-residential areas, sewage flow is estimated of course zone wise, and for mixed use zones or for other zones, sewage from institutions, commercial buildings are estimated based on the water that is supplied to them. That means, as you know from our earlier lecture, that different institutions like hospitals, hostels are supplied with different kind of water. So, like hostels 135 LPCD, for hospitals including laundry and beds exceeding 100, 450 per bed. Then if there is restaurant 70 per seat, cinema hall 15 liters per capita per day, factories 45 liters per capita, offices 45 liters, and so on. So, using these figures, we can assume that whatever is being consumed in this particular building, so that would become the sewage, maybe some losses would be there. So, based on that, we actually have to estimate that for certain special zones which are not industrial, sorry, not residential, in that case, we have to estimate the water that is supplied to these particular buildings, and from that we need to determine what kind of sewage would be generated. And then industrial effluents in public sewage may be harmful to sewage treatment. So, usually we follow a zero discharge policy. That means, most of the industries are not allowed, but if they have a effluent treatment plant, if they have a sewage treatment plant, and then the effluent could be, if it is treated to certain standards, then we can allow it to release water inside the municipal drains as well. So, but if directly it is we allow this industry to put water, put the discharge into the sewerage pipelines, it may actually affect the biological or the secondary treatment that we adopt in this sewage treatment plants. So, usually we do not allow them. So, polluting industries within the city limits should reuse effluents after treatment. So, they are not even allowed to release their effluent. So, zero liquid discharge is the policy that we follow, and particularly this has to be maintained for automobile service stations, machine shops, and which actually have got a lot of oil and grease, that this actually if we allow them to release water into the municipal drains, they actually release this kind of oil and grease into the system, which actually messes up the entire system. So, there has to be prevention for that. So, even though in Indian cities we try to follow a zero discharge, but sometimes these rules are not followed. So, that is one big challenge that we have to overcome. So, as you understand, if we want to do this kind of detailed estimates, we need to have the land use base map, the building use map, and based on that we need to determine the sewage flow. So, the entire maps are required to determine the total sewage that is generated from an urban area. We cannot just take what is the municipal supply and then multiply 80% and say that this is the sewage flow. Then you will end up with the estimate should be wrong. So, I think that though people do cut corners and do those kind of estimates, but you need to do this detailed calculation to estimate zone wise sewage flow. So, what is the net quantity of sewage? So, to summarize, it depends on the type of area served. If it is residential land use, we can go with population density or FSI, per capita sewage flow, fluctuations in flow, all these things needs to be considered when we determine the sewage that is generated from residential land uses. Other land use and building uses, water supplied to buildings, we can assume a factor of around 80 to 90%, and that can give us the total quantum of water sewage generated from this particular buildings. Groundwater infiltration, we can follow the thumb rules and we can assume certain values. Then these are the additions to the system. What are the subtraction? Wastage and leakage in the pipeline during distribution, water used in drinking, washing, gardening, etc. Evaporation around 20 to 30%. So, there are certain things which gets added, then there are like groundwater gets added, but there is evaporation and all these wastages are there. So, usually we assume like 80 to 90% of the total water that is consumed in the city becomes sewage. So, it is total water consumed, it is not only the water that is supplied by municipal bodies. So, the net quantity of sewage could be said as accounted quantity of water supplied from water works, from municipal supply, addition due to unaccounted private water supplies. This is tube wells, wells, everything used by different residences or real estate projects. Addition due to infiltration, minus subtraction due to water losses, subtraction due to water not entering the sewerage system. So, these are the different things. Overall, we take 75 to 80% of accounted water supply is considered as quantity of sewage produced, but as you understand that 75 to 80% in certain seasons it is fine, but during rainy seasons and in certain other seasons this value actually increases to even 90%. In case of combined sewer, storm water also has to be estimated. So, that is in excess. So, we have not talked about storm water actually, we are just talking about the sewerage pipelines. We are talking about the sewage pipelines, but if we consider storm water as well, or we consider combined sewer systems, in that case we have to do detailed estimates for storm water. So, we will take that up in the next lectures. So, to conclude, sewer designs are based on peak flow rate. Net quantity of sewage is estimated for different zones and different land uses separately. So, these are the references. Thank you.